Hey everybody, I'm Eric, and this is going to be a visual wiring diagram for a Yamaha G1 two-stroke golf cart. I realize that 99% of the people out there, and this might as well be hieroglyphics on the screen, it's going to shut off in a few seconds. Okay, I'm not going to teach you how to read an electrical schematic. That would take years to get to where I'm at anyway. But I am going to translate every single wire on that machine into reality for you with a ton more information that you can use to test your different switches and your relays and understand how everything works. So when you go to troubleshoot this machine, it's going to be a lot less frustrating and guesswork. Okay, I hate guesswork. Okay, they make voltmeters and ohm meters to test these things so you don't have to guess at what's wrong. All right, now it's a very complicated system in itself. I mean, for most people, it would be complicated. I've been doing this for almost 40 years. I'm an electrical engineer, and I've been studying way more complex systems than this one. When that screen shuts off, it's not going to bother me. I have the whole wiring diagram memorized in my head. Okay, so you may get confused along the way because we have what I consider three different systems: the starter, generator, and the solenoids. We have a control circuit system, and we have an ignition system, and they're all tied together. Hard for me to describe any one system without talking about the other. Okay, but I'm gonna try, and I'm gonna start with the starter generator because I think that's maybe the more confusing part. This big octopus of black wires that are all connected to your starter. Okay, so let's just talk about the actual connections of these. You can see my starter generator's in pieces because my lug broke off where my positive cable should attach to the F2 terminal, and that lug is integral to the whole winding, so I'm screwed. Okay, either gotta replace those windings or buy a new starter. That's how it goes. But like I said, this is what we call the F2 terminal. We have F2 and we have F1. Okay, we also have A1 and A2. Field windings, which are putting sending electricity around these windings on the outside, and the armature windings. We're sending electricity into the armature going through the center. Okay, this generator, this starter function part, let's say, I could apply 12 volts to the field and 12 volts to the armature separately. Okay, and that would cause the starter to spin. Or I can wire them in series, which is what we do on this machine. I'll have 12 volts going into the field. I come out of the field with the 12 volts and I jumper to A1. And I go from A1 through that windings to A2 to ground. Okay, so I'm making a circuit in series with these two windings instead of energizing them separately. Okay, and this is what we do. And all we do to reverse that direction is now connect that jumper from F1 to A2 and A1 to ground. Okay, it's real simple how we reverse the direction. If you put a new starter in, it's going the wrong way, swap these two terminals. That will correct it. Okay, and the method by which we reverse that is done through two solenoids. Okay, and once again, this looks like a big maze of jumpers and all kinds of excess stuff here. And it really seems confusing. It's really pretty simple how it functions. Like I have here, usually you should have the forward solenoid on the left and the reverse solenoid on the right. Those are known because the yellow wire feeds your forward solenoid and the lavender wire feeds your reverse. Okay, I consider this the top of the solenoid. I'm going to move this out of the way. These solenoids are nothing but big relays, okay, with two sets of contacts in each solenoid. They both react the same way. There's a set of contacts in here that in the off position is not touching these two contacts. It is normally open, okay? We have another set of contacts inside that relay that is making contacts in here in the off position. Those are normally closed. When we energize that yellow wire and the black wire on the other side, we need a ground. That causes the solenoid to shift, which will open these contacts and close these contacts. Okay? This is all that's happening when we energize a solenoid, just shifting those contacts. And so now let's talk about how the generator is wired to these solenoids. You'll notice on here there's jumpers connecting the two solenoids in the center, okay? And you also have these jumpers on the outside, these bridges of both solenoids, okay? It looks very confusing. It's actually very simple. Now on the solenoid, on the generator, starter part, excuse me, this is the actual generator output. We'll talk about that in a second. On your starter, your positive lead off your battery cable, okay, your main positive lead connects to F2, okay? Your F1 cable is going to come up through your harness, and it's going to go up, and it's going to tie into the center lugs on the top of your solenoid, okay? It can be on either one, doesn't matter. They're bridged together, okay? That's where your F1 terminal goes to. Your A1 and your A2 cables are connected on the bottom here, your A1 and A2. Once again, if you're going in reverse than what you want to be, you can also swap these two cables here. We'll do the same thing. We'll reverse the direction of your starter. Now, the way this operates, in the off position, where both of these off, all these terminals are tied together between the jumper wire and the solenoid being closed. We have 1, 2, 3, 4, 5, 6 terminals that are all connected to your negative battery post, okay? Remember, this is not ground necessarily. It's not chassis ground. This is negative battery, okay? Between that negative battery, we have a fuse between there and our chassis ground, all right? This is very unusual. You very rarely see this in any kind of a vehicle. This is because we're separating the chassis ground, we're protecting chassis ground from the battery ground. Because this system will send that voltage through here, and you want to protect, you don't want to send that voltage all the way to your chassis, and that's what this is for. It's protecting your chassis ground from the battery ground. It's very unusual. Now, when we go in off position, all those are connected to ground, and the F1 terminal, which is connected here, is not connected to anything. It's tied to this terminal, and they're not connected to anything. When I select forward and I push the gas pedal, that will send voltage to the yellow wire, energizing this solenoid. So I shift this set of contacts. That means F1 will now bridge to this terminal and come down and connect to this wire, which is A1. This set of contacts will have opened. So now A1's not connected to ground anymore, but A2 is. And that's completing my circuit. I go 12 volts on the battery. I come out F1. I go into F1, into A1, and A2 is connected to ground. I've completed that circuit. Let me show you visually how that happens, okay? In the off position, F1's not connected to anything. F2 is on positive 12 volts always. A1, A2 are connected to your battery, negative battery. And forward, when we energize that solenoid, F1 and A1 are now connected together. 12 volts is still on F2 and A2 is still on ground. That completes the circuit and allows the starter to turn. When I select reverse, okay, when I select reverse, that energizes the violet wire in this solenoid. Now, when this energizes, that connects F1 to A2, okay? So here we have it. In reverse, F1 and A2 are connected. F2 still 12 volts, and A1 is now ground. So this will make the starter turn in the opposite direction. It's really not that difficult to understand. It looks a lot more complicated than it is. We're making one wire swap with all this. All we're doing. Now, the control circuit part of this has a lot of interconnections between start, stop, and forward reverse switch and the ignition system, okay? This is very confusing. It's not that apparent if you don't know how to read the schematic. So first I want to start with the main power. I've already explained to you the ground. Let me finish that though. This ground, this fuse, which is obviously not factory, goes back into your control system and feeds all kinds of things. It feeds your relay, it feeds your voltage regulator, it feeds up, that black wire feeds up into your start stop switch. It also feeds in your forward reverse switch. And the grounding points are here. One is right coming off your chassis is here. You have one grounding point with that same black wire. It's all tied together. Here on your ignition coil, I have another black wire going down to our stator plate or our magneto. Okay, all that is connected to the body of that stator plate. It's not connected to your coils. Okay, so that's your ground. All of our 12 volts starts here on this wire that connects to your battery cable. Mine was completely severed, so that's why it looks this way. It should be a red with white wire. Okay, this red and white wire is used in multiple places and they're not tied together, not yet anyway. So be careful, because this red and white wire is the wire that comes up and feeds through your second fuse. Once again, this has been replaced. It should have a 10 amp fuse. Here you can see the red and white, okay? So the red and white now goes to 3 different places. This is very important where this feeds power to. Only 3 places. One place is your relay, okay? Your main relay. We have the red and white wire here, okay? That comes directly from that fuse. The second place it goes to is your start-stop switch. Right here, we have another red and white wire coming to our start-stop switch. And it also changes color to a solid red and goes to your forward reverse switch. Okay, well, why does it change color? Well, because there's a different red wire already on this harness that we'll talk about in a second. And the only purpose of that red wire, this is a point that's actually incorrect in that factory schematic, is that when you put the key in reverse, that red wire will close a set of contacts in reverse and send 12 volts to the pink wire. The pink wire is doing one thing. That's feeding your reverse buzzer, okay? That's all that red wire is there doing, is feeding your pink wire, which mine has been cut, okay? Going to your reverse buzzer. Does it serve no other purpose? That red wire serves no other purpose in this switch other than to feed the pink wire. The factory diagram is incorrect. I'll show you in a second. Now, so the whole sequence of events that happens once we have the 12 volts to those places, first thing that has to happen is actually activating the stop switch. First thing that has to happen. When I push on the stop switch, the red and white wire that's coming from our fuse will make a contact onto the white wire, okay? That white wire goes to one place only, and that is our main relay, okay? And so you'll see here, we have this is that white wire, the one on top. It goes to our relay. Excuse me, it's the one on the side, right here, this one here. I tried to draw on here, this is the coil side of this relay. We have a ground, and when we hit that stop switch, when we hit that gas pedal, it's going to send 12 volts to here, and it's going to energize this relay. Okay, it's the first thing that has to happen. If this relay doesn't energize, nothing's going to work on your cart. Once the relay energizes, we have that same 12 volts from our fuse, red and white wire here, and set of contacts closes and sends 12 volts out this white wire. A different white wire, okay? Now we have voltage on this white wire. Now that white wire is the white wire that comes up on your forward reverse switch. Okay, that is this white wire right here. That is the switch that actually feeds everything, that makes everything happen. Okay, now what I'm going to do is show you the positions of these switches and the wiring contacts that are made when you're in the different positions. Okay, this should help explain a lot of what's going on this machine. So once I have pushed the gas pedal on, my relay energizes, and I have power on my 12 volts. If the key's in the forward position, that will make contact between the white wire, a different red and white wire, and the yellow wire, okay? Obviously, I just showed you the yellow wire energizes the forward solenoid. Makes sense. So I'll put 12 volts on the forward solenoid. What is the red and white wire? This is actually a separate red and white wire. This is coming from our generator. Okay, this is power to get the engine started. This is power to keep the engine running when we're on the generator. Okay, I'll explain where that red and white wire comes from in just a minute. In reverse, we have the same white connected to the same red with white, now connected to the lavender to energize the lavender coil. Okay, so we see how the two solenoids are energized by pressing the gas pedal, energizing the relay, and then we'll send voltage to our solenoids, right? Also, a couple other things that are happening on that same forward reverse switch. One is, when you're in the off position, the black wire, which is ground, is connected to a black with white. Well, what's that doing? That black and white wire is used multiple times, and this is a wire that's coming off of your ignition box, and when this wire is grounded, it will kill your ignition. So in the off position, we're grounding the black and white wire, killing our ignition, okay? In forward and reverse, we're also connecting the ground, black, with white with green. What's the white with green? White with green is also coming from our ignition system. This is forming a ground for one of our two coils on our ignition system. Until we create that ground, that coil will not produce the energy it needs to trigger the release of spark to your spark plug, okay? So when a guy writes in after he's tore his whole magneto and everything apart, because it runs in reverse but not in forward, and he thinks it's a timing issue, it's really a problem because the switch is bad, okay? I have one right now, my old switch. It makes continuity between white and green and black in reverse, and does not in forward. There's no way this machine would have worked in forward if I would have tried it, okay? And we also see here that red with pink that I just described to you happens when you put it in reverse only. And this is the error in the factory diagram that shows all four of these wires connected together. That is incorrect. If we did that, we'd be putting 12 volts straight to ground. We'd have nothing but a meltdown sending 12 volts into that coil, which is connected to ground. Would not be good sin. This is incorrect on the factory, okay? That is your forward reverse switch. I just explained to you a minute ago how the white connects with red and white on your stop switch. When you have the accelerator pedal off, you also are making contact, once again, killing your ignition with the black to black and white, okay? Two ways of killing your ignition. On the stop switch, and also your main switch, and two other ways of killing your ignition by not grounding the pulsar coil in your ignition system, all right? So, I want to explain where this red and white wire comes from right here. This is also very confusing. Off of your generator, you have a red wire and a green wire. Connects to a red and green wire in your harness. Not far into your harness, this red wire is going to convert to a red with white wire. Okay? It's no longer going to be red. And it's going to go to two places. One is your main switch. This is that red and white wire right here. And the other place is your voltage regulator. Okay? Like I told you before, we use the white wire off the battery power to get the engine running. We're running off of red with white wire once it's running. We're using power from the generator itself. The green wire on the generator connects directly from the generator to your harness to the box to your voltage regulator. No other connections. And we once again have a plaque on here. Okay, so all this is done right here except for the ignition box. Okay, so ignition box, you have three components. We have the CDI controller, which is a capacitor discharge ignition system. Inside of this box is a big capacitor. Okay, we have the ignition coil itself, and we have what I call the magneto. Some people call the stator plate. We have two coils. You have a source coil and a pulsar coil. Okay. The source coil is what's developing the energy for this system, Okay, as that magnet's spinning around, that source coil is sending that energy through the brown wire. Okay, the brown wire coming out of your harness right here on the bottom, right here, brown wire feeds directly into your CDI box. Okay, right here, brown wire. This stores that energy in a capacitor in here. To release that energy, we need a trigger. That's coming from our pulsar coil. Okay, that's a white with green and a white with red wire. Okay, white with green, white with red. They come directly to your CDI box, and like I just explained to you, none of that coil is going to work until we ground that same white with green through our forward reverse switch. Okay, that is this white with green. We have to ground that, or that pulsar coil is not going to function. If it only works in one direction, it's probably because your switch is not working, not because any of your magneto is not. Okay, so once we trigger that with that source coil, the release of that energy will come out of the orange wire, and it will feed into our ignition coil, where that voltage gets multiplied many times over and sent into our spark plug. Okay, there's only one other wire, two other wires here on this box. One is the black and white wire that I showed you before. This is your ignition kill. Okay, when you ground this wire, that kills this box intentionally. That's what that wire is designed for. And we also have just a basic black wire just for the functionality of the box itself. Okay, I'm pretty sure that's every single wire on this machine, guys, believe it or not. I know it's like 20 something minutes, but it's not that difficult once you see it in reality. You can use certain things that I have here. Take a screenshot. This is how your relay works and the wires that are connected to it, what it's doing. Here I write on here, from the stop switch is your white wire, energizes the coil with the ground, and now we send red with white from our fuse to the white wire, which is going to our forward reverse switch. Very confusing, two white wires, multiple different red wires. Here's your start stop switch. It's exactly how you should be able to test continuity across your contacts in the two different positions. This is how you test continuity of your main switch. Okay, this is actually, you energize the coils with no, you can energize these coils with no main cables connected, and you could test continuity. Same way on here. We have these are basic resistance measurements I made of my ignition coil. I don't even know if it works. I've yet to start my machine. So, but this is the measurements I got. These are definitely measurements that I read online and I got for testing your two coils in your magneto. The ones in parentheses are the measurements I got off of my coil. Okay, I haven't verified these other voltage readings while it's there. Okay, so hopefully this will explain a lot of stuff. It should be eye-opening to you guys how all the interlocks work and where actually every wire goes. And I know it's a little bit lengthy, but I know it's also, I'm hoping it's going to save you tons of frustration and guesswork when you go to troubleshoot any problems you have with electricity on this machine. So appreciate everybody's time, and thank you very much for watching.